Hello everyone, let's continue our course. After MME receives this initial UE message, MME will understand the purpose of the UE. If UE wants to perform a attach, now MME will start the authentications and the NAS encryption procedures. Check the ID of the UE to see if this user is a legal user or illegal user. This procedure's authentication is a NAS procedures, which is transparent for the radio access network. For the GSM and also for the 2G and the 3G, we all have these procedures, authentication. Same in the 4G. These procedures between the UE and the core network is not related with the radio access network, no matter our radio access network is 2G or 3G or 4G. It doesn't matter. It's just related with users and only the core network. Authentication is a NAS procedures. Here we will use those NAS signaling to perform the authentication. After authentications, we will have the NAS securities. Authentication check the identification of the user. And here, NAS security. User, UE, and the core network, they will discuss about the key and the ciphering algorithms for the encryptions and the decryptions. After all of these procedures is passed and succeed, then we will go to these procedures. Initial UE context setup procedures. If this user is a legal user, pass the authentications and the security mode. Now we will set up a default barrier for this user. This default barrier is released only when the UE exceeds the PDN. Here, the PDN, we consider the PDN as a PGW, just like a PGW. If UE connect with the PGW, PGW will allocate an IP address for this user. Once user get an IP address, user will keep IP connections with the network. This default IP connections, we consider it as a default barrier. That's the definition for the default barrier. We can consider this default barrier is just like a default IP connection between the UE and the PGW, between the UE and the PDN. When we will allocate this default barrier after UE pass the authentication, during the attach procedures, we will set up this default barrier. And this is the start point for the setting up the default barrier, initial context setup request. And this is the endpoint, initial context setup response, the endpoint of the default barrier setup. This red circles shows the whole procedures for the default barrier setup. This is the start point and this is the end point. Let's see the details for the initial UE context setup procedures. This is the request message. This is the key information, key parameters in the initial context setup request, including this information. For example, the UE aggregate maximum bitrate, the downlink and uplink, and also including the ID of the UE and the eNode B. Besides the UE aggregate maximum bitrate, we can also see some other parameters like this eRAP ID and the QCI. Here, QCI here means quality of services class indicator. For the quality of the services, we call it QoS for short. Different services, they have different QoS requirement, but in total, we divide all the services into 9 different classes. Here, each class we use our ID indicate them from QCI 1 to the QCI 9. QCI 9 has the lowest priorities. If a services belong to the QCI 9, this means these services has lowest priority. The default barrier we just mentioned actually belong to the QCI 9 because default barrier is just a default IP connection. All the user, as long as they attached with the network, as long as they get an IP address, has an IP connections, all of these users will have this default connection. So for this default connection, also has some QoS information, have some QoS requirement, but the priorities for those QoS is lowest, it belong to the QCI 9. Okay, the QCI 9 is for this default barrier. And besides the QCI information, we can also see some other QoS information. For example, here, allocation retention priority. We call it ARP for short. ARP actually is the priority for the users. We set the ARP for different users in the HLR. In these examples, the priority for the users is 6. Also, we can see some other parameters like the UE security capabilities and also the security keys and also the handover restriction list. All of this information is included in the initial UE context setup request. Generally speaking, the initial UE context setup request message, including the QoS information, QoS parameters of the default barrier. Kernel work send this QoS message to the eNode B, and the eNode B will allocate the radio resource for the default barrier based on the QoS information, based on those QoS information. And this is the response message. After eNode B finish the radio resource allocations, the eNode B will send initial context setup response message to the MME, which means the default barrier setup is finished. Let's see some key information element for the initial UE context setup response message, including the MME UE S1 AP ID and the eNode B UE S1 AP ID. We use this ID identify a user uniquely in the S1 interface because we know that S1 interface between the eNode B and the MME will be used by many users. We must have a user. We must have an ID identify each user. S1 connections should be dedicated for each user. And this is the ERAP setup item context setup response message, okay, including the transport layer address. Okay. AS security setup is optional procedures during the default barrier setup. AS security setup here, AS here means access stratum. This security setup actually is between the UE and the eNode B. The signaling between UE and the eNode B we call it RC signaling. RC signaling also need integrity protect and also need deciphering. This AS security setup message is between the UE and the eNode B. Actually, this is the message for the AS air interface radio security. RC security mode command, RC security mode complete. And also, these procedures, UE capability query process, also is an optional procedures. If in the initial context setup request message, MME will tell the eNode B the capabilities of the UE. If inside this message, MME doesn't tell the eNode B the capability of the UE, then the eNode B will send this message, RC UE capability inquiry to the UE, in order to ask the capabilities information from the UE. And the UE will reply this RC UE capability information to the eNode B, report the capabilities to the eNode B. And after eNode B get the capability information of the UE, eNode B will send this UE capability information indicate to the core network. This procedures is optional. Once core network tell the eNode B the capability of the UE, then we won't see these procedures anymore. Here, this is the key informations for the UE capability query. We can see this. This is the red type. The red type supported by the UE. This is one of the capabilities of the UE. And also, we can see UE categories. In these examples, the UE categories equals 4. For the LT 3GPP release 8, we defined 5 different UE categories. The higher the category numbers, the higher the UE capabilities. Here, in these examples, is 4. And also, we can see some other frequency band capabilities. This is the supported band class for this user, for this UE. And also, the interfrequency measurement capabilities. And also, the feature group indicators. These feature group indicators indicate the feature capabilities of the users. Some features supported or not supported by this UE. After the RC security mode and the UE capability inquiry, after these 2 procedures, then we will start the RC connection reconfiguration procedures. I just mentioned, if MME asks eNode B to set up the default barrier, MME will tell the QoS information to the eNode B related with this default barrier. And the eNode B will allocate the radio resource based on the QoS requirement. And these 2 messages, RC connection reconfiguration and RC connection reconfiguration complete. This 2 messages actually is used for the radio resource allocations. eNode B send these 2 messages to the UE, send RC connection reconfiguration to the UE. UE will reply the complete message to the eNode B. These 2 messages between the UE and the eNode B actually is used for the radio resource allocation. Here, we will allocate the SRB2 and the DRB. Here, SRB2 means the radio resource for the signaling. DRB here means the radio resource used for the data. SRB2, almost the same like SRB1. SRB1 for higher signaling, SRB2 for lower priority signaling. And this is the key information element for the SRB2 DRB setup. We can see here SRB identity 2. And here DRB 2 add mode. DRB identity 1. Set up SRB 2 and the DRB 1. And all of these informations, including the MAC, main config, physical config dedicate, all of this is for the radio resource management, radio resource allocations. eNode B will allocate the radio resource according to the QoS requirement. After we set up the default barrier, finally we will release it. The reason for the S1 dedicated signaling release here may be eNode B triggers. For example, the detect UE is in user inactivity for a long time, or eNode B OM system trigger. OM here means operation and maintenance, or MME OM system triggers. Anyways, if one of these reasons happened, we will release the signaling connections. First, release the S1 connections, then release the RC connections. This is the procedures for the S1 signaling release procedures. Before the S1 connection is released here, this is the case. eNode B and SGW, they have a connection for the user traffic. And the MME and the eNodeB, they have a connection for the signaling. After we released S1 connections, between the eNodeB and the MME, there's no more S1 connections. And between the eNodeB and SGW, there's no more user data connections. And also in the air interface, our bridge RC connections is also released. And this is the key information element for the release. Here, this is the MME UE S1 AP ID and the eNodeB UE S1 IP ID. And this is the course of the release. From this course, we will know this release is a normal release or abnormal release. Here, in these examples, the reason of the release is user inactivities. This is a normal release. Let's have a summary for these sections. In these sections, we discussed the RC connection setup procedures. For RC connection setup procedures, we have 3 signaling. RC connection setup request, then RC connection setup, and last, RC connection setup complete message. In total, 3 messages. And also, after these 3 messages, after we set up the RC connections, UE will send initial UE message to the core network directly in order to tell the core network what is the purpose of the UE. For example, maybe UE want to perform attach procedures, or maybe UE want to set up services. After this, the core network will initiate authentications and NAS security procedures. After UE pass the authentications and the NAS security procedures, core network will set up the default barriers. First, core network send the initial UE context setup request message to the eNodeB. After eNodeB allocate the radio resource, eNodeB will reply the initial UE context setup response message. And this message, RC connection reconfiguration message, actually is used for the radio resource allocations. That's all for these chapters. Thanks for watching.